we've been working with both of these equations. So we've seen equations that look kind of like both of these things for our arithmetic sequences. But I want to point out some different connections with places numbers are showing up. First of all, if you look in here, got a 1, got a 5. Where else do we see a 1 and a 5? Right where?
At the beginning.
Oh, that's a coordinate, isn't it? I could come over here. I've got a 2, got a 6. Where else do I see a 2 and a 6? Do you guys see the coordinate that's hiding in that equation?
I see a pattern.
Ah, so you guys have been writing equations like this. You may or may not have noticed, which makes sense because this second part is going to be offset based on wherever the pattern starts, whatever point it starts at. So that coordinate is always going to be hiding in here. This format of equation actually has a special name that you've been working with without even realizing it. And in order to understand that name, where did the 2 and the 3 come from in both of these? What were those? What was it? Oh, yeah, those are the common difference, right? So what's another word for common difference? Sometimes we call the common difference the slope. Oh, so this type of equation in algebra, it's a type of equation you can write for an arithmetic sequence. It's called a point-slope equation because there's a point hiding in there and the slope, which is the common difference. Useful information. Let's come down to the last part of this. The last part of this asks you to find the value of 0, right? It makes sense to probably use our simplified equation because it's faster, right? So if I put an input of 0, what am I going to get out?
0.
Okay. Let's come over here to the second equation. If I put in a 0, what am I going to get out? Okay. This said mark the value on your graph. So let's do that. So 0, 2, right there, right? 0, 10, right there. Where do you see these numbers? They're on the graph. I've got a 2, I've got a 10. Is there anywhere else where you see that 2 and that 10? In what?
In the equation, simplified.
Oh. So, what we can get out of this, we introduced this idea when we did our explicit equation cheat sheet. Claire, thank you. The idea that we can make an equation that is the common difference times the input plus the start value. But there's a catch on this. The start value has to be if we're starting where? At 0. If we're not starting at 0, then we need to use this type of equation. This equation is called a slope-intercept equation. Slope, because slope is another word for the common difference, which shows up in the equation, right? Intercept comes from this part. When I'm at 0, where am I always at on the graph?
Origin.
Yeah, well, yeah, I'm measuring up from the origin. I'm going to be on the y-axis. And where you touch the y-axis on a graph, that's called the y-intercept. So that's why this is called a slope-intercept equation.